Yeah, son. Good morning or good afternoon, 7th grade honors and 8th graders. We are starting chapter 3 today. We're going to discuss constant rate of change. Sounds kind of scary, but it's super easy. Just think of it. Constant rate of change. Is something changing at a constant rate? Is it changing at the same rate each time? So just think about it like that. I do want to review if a graph is proportional. We know that it has to be a straight line and that it has to travel through the origin, which is 0, 0. So you can have a graph that has a constant rate of change, which means it would be a linear, which linear means line, straight line. So it is a straight line. But if it does not travel through the origin 0, 0, then it would not be considered proportional. However, it could be considered linear because it has a constant rate of change. So I hope that makes sense. And that's the bell, but nobody's here today because it is a work day for teachers. So in just a second, I'll do a screen recording. I'll do some work up here, and we'll get this party started. All right, guys, so we're going to start in with constant rate of change. I just got this little PDF from the textbook. I want you guys to remember you can go to the textbook at any point in time and get all extra practices that you may need. So I've sketched the table up here. This table looks like the one on your screen because it is going horizontally, but I want you guys to know that you definitely could see a table going up and down. It doesn't always have to be going horizontal, so I just wanted you guys to know that. So what we're going to start with is it wants us to determine whether the relationship between the two quantities shown in each table or graph is linear. If so, determine the constant rate of change. If not, explain your reasoning. Okay, so you can see up here really super easy that my time is constant right here. The top part is constant because it's changing by +1 each time. So it's 1 + 1 is 2, 2 + 1 is 3, 3 + 1 is 4. So the top part is a constant rate of change. So I'd say yes. So now we're going to do the bottom, and you're going to want to have your calculator for this. And I'm going to do 8.6 minus 4.3 to see what it is. I got 4.3. So right here, this is plus 4.3. I hope you can see the decimal on your screen. May not. All right, so then I'm going to do 12.9 minus 8.6 to see what it is right there. 12.9 minus 8.6. And it is 4.3. Now, a lot of times, you kids, you guys will stop right there. You can't. You have to go all the way through to make sure that that rule is working every single time. Because you could say, oh, yes, this is constant rate of change. But I can tell you right now, this right here is not going to be because I can tell. So let's do 16.3 minus 12.9. Okay. And this right here changes at it's +3 4/10. Okay, so I'm going to say that this is not a linear. This is not linear because it's not going at the same rate every time. So yeah, at the top, this part is constant, but down here is not constant. It's 4.3 here, 4.3 here, but over here in the 3 to 4 minutes, when we transfer from 3 to 4 minutes, we're only going up 3.14. So this example would not be linear because if you plotted this, if you looked at this as your X and your Y, and you went on a graph, a coordinate plane, let's say you had one, and I don't know, you know, these are your X's and these your Y's are up and down your exercise. So you go to 1 and then you go up to 4.40, 4.3, well, I don't know, right there, and then they will all be linear until you get to 4 and you go to 16.3, then the line is going to be kind of jagged. All right, so just so you know, yeah, the top part's constant. The bottom part is not constant. Okay, so we're going to skip on to the punch recipe number 2 next. So if you want to pause and start writing down the table, I'm fine with that. So now we're back with example 2, and it's a punch recipe. And so apparently they're putting soda and juice, and these C's represent cups. So for 2 cups of soda, you're going to put in 1 1/4 cup of juice, 4 cups of soda, 2 1/2 cups, 6 cups, 3 3/4, and 8 cups is going to be 5 cups of juice. All right, so let's review this. I need a different color, peeps. Got purple. Actually, let me do a contrasting one. All right, so this is going up by 2 each time. +2, +2, okay? So top part again, just like last example, top part is constant, all right? I'm good with that. Now look, we've got 1 1/4, 2 1/2, 3 3/4, and 5. You can totally go to your calculator and you can put all these in fraction form. You can do 2 1/2 minus 1 1/4, find the constant rate of change there, or not constant, sorry, the rate of change there. You can do 3 3/4 minus 2 1/2, find the rate right there, and then 5 minus 3 3/4. But you should, at this point, being 7th grade honor students or 8th grade math students, you should know that 0.4 1/4, if you just go ahead and divide it, 1 divided by 4 is going to be 0.25. So you can't see on the screen, but on your calculator, if you use it, it's 0.25. So this is really 1.25. This would be 2.5. If you want to write it down, it's fine. If you don't, it's okay. You don't have to do the 2 1/2. You can just do, I'm going to change this to 1.25 because 1/4 decimal equivalent is 0.25. 1/2 is 2.5. Now, listen, you can just divide 1 divided by 2 and you're going to get 0.5 if you put it in your calculator. And if we do 3 divided by 4 in the calculator, you're going to get 0.75. So 3 divided by 4, 0.75. It's really handy if you can know the decimal equivalents to common fractions. So, and like think of it as quarters. 1 out of 4 quarters is 25. And if you made this to 4, it'd be 2 out of 4 quarters, which is 50. And then 3 quarters out of 4 is 0.75. And then we have 5 whole. All right, so if I'm just changing this because for me, it does not have to be you. You can go in there and you can do the alpha, y equals or stat plot up here, y stat plot, and then you can click number 2 and make it into mixed numbers if you so choose. And you can do 2 1/2, and then you can do minus, and then you can do alpha, and then stat plot 2, and type in 1 1/4. You're going to get the same thing, only in fraction form. So it doesn't really matter which way you do it. I prefer decimals. I like them better. It's my opinion. You don't have to do it this way, but this is the way I'm going to show you. So if you want help doing the fraction way, raise your hand, I'll come help you. All right, so if we do 2.5 minus 1.25, you're going to get 1.25. So this constant rate of change right here is 1.25, okay? Now, 3.75 minus 2.5, and we have 1.25 again. All right, now we're going to do 5 minus 3.75. 5 minus 3.75, and we get 1.25. And we know that that's the same as 1 1/4, or you could say 5/4. Same thing. I mean, it's whatever is easy for you to understand. Now, so this bottom part is going up by the same each time. It's moving up by 1 1/4 each time. Okay, so this is going to be a linear relationship, and this is going to have a constant rate of change. Okay, so the table or the graph would be linear. If we graph these points on a coordinate plane, if we graphed our x's and y's, it would come out, it would be a straight line, it'd be linear, because it's moving up by the same amount each time. All right, so if you have questions on that, please raise your hand. I am here to help you. So next we're going to use a graph. Sorry, I'm trying to get out a little bit. We're going to use this graph to answer the constant rate of change. All right, so I hope that what you all are seeing with the first 2 examples, and then you'll be able to see it more clearly with this example, that we're getting into slope of a line. I'm not sure If you learn about y equals mx plus b and the slope, how it goes up and over or down and over, but this is what we're leading to. So make sure that you really understand this, because if you understand this, slope of the line is going to be super simple. All right, so they've given us a ticket profit graph right here. And I'm just want you guys to know I'm probably not going to do this one over here simply because we're running at a really lengthy lesson today, and I don't want to take up all your time. You won't have time to practice this skill to make sure that you've mastered it. All right, so this is ticket profits. I just made my own table right here, and my X's would be number of tickets, and then Y is going to be your profit. All right, so I just changed it easy for me and made it X and Y. So what you'll do first is you always start at the origin, and this is your X, and it obviously tells you right here X and Y up here. So we go over 1, 2, or actually 4. We go over here to 4, and we go up, and we're going up to 20. So my X for this coordinate, the X is 4, and then my Y is 20, okay? So the next one, we go over, the dot is here. I don't know if y'all can see it very well, but we go over, and these are going up by 2 each time. 2, 4, 6, 8, 10, 12, 16. All right, so when we go over here to 8, where the blue dot is, and then we go up, it's at 40. So the X on this one is 8, and my Y is 40. So basically, when you buy 4 tickets, it's $20. 8 tickets, it's 40. All right, and the last one, let me separate that real quick. If we look over here, we got to go, you always want to remember when you're looking at graphs, you've got to walk across the lobby of a hotel before you can take an elevator up or down. Or you have to walk across your floor to get to your elevator before you can take that elevator up or down. That always helped me remember. Not sure if it will help you, but it certainly helped me when I was learning. Okay, so now we're going over here, and our first X is 12, and we go up, and it's at the 60. So our X is 12, and our Y is 60. All right, now, clearly we can see easily that this is going to be a linear, we can see that this is linear, and it actually is proportional because it would travel through the origin. All right, you also always need to do at least 3 points. I will say that's always been told to me. I don't know who came up with that, but you need to do at least 3 points to make sure that you get the slope of the line correct. All right, so this is going up by 4 each time. Okay, so this constant rate, this is a constant rate of change, and this is increasing by 20. Okay, now if you looked at this and you're like, okay, you could pick any one of these. You could do 4 over 20, or you could do 8 over 40. It doesn't matter. Either way, when you reduce these, if you reduce them, you can find the slope. So, or you could do, if you wanted to figure out how much would one ticket cost. Okay, well, one ticket, let's just reduce. Let's find the unit rate or whatever you want to say. Or let's, not the unit rate, let's reduce this. So if I reduce this, 4 will go into 4 and 20 evenly. 4 goes into 4 one time and 20 5 times. Okay, so the slope of this line is 1, 1, 5, or it actually, slope is y over x. So it's actually 5 over 1. Don't worry about that right now. I shouldn't have brought it up. But you know that if you wanted to find the unit rate, one ticket is $5. But actually, we need to flip-flop it. And if you divided both of these, 8 will go into both of those. Okay? 8 divided by 8 is 1, and 40 divided by 8 is 5. It's still 1/5. Okay? So this was a constant rate of change, and we found the slope. Okay? Now, the next example may or may not have been a constant rate of change. We're not going to go into it because you still have to practice this skill. So if you have questions, please raise your hand, ask me. You can come in tutorials, you can email me. We can do whatever to help you, okay?